Let them join. Okay. So you are recording this meeting, so everything is good now. So we will get started. Okay, let me disable my camera. Okay. Okay. So let's go forward. So before that, let me give a quick introduction about me. So who is this, and what is this Citron Technologies, and what is this today's demo is about? Okay. So today we're going to talk about AWS Machine Learning Specialty Certification Program, what AWS has, what it is called Amazon Web Services Cloud Platform. So, and we're going to see not only that session is not just dedicated to AWS machine learning specialty certification course. It's much more than that. Obviously, we're going to explore the job opportunities. What is the impact of ML and AI in the world right now? What is going to happen in next 10 years? What are the opportunities? What type of opportunities are waiting for the working professionals, for the students, or the professors, or whoever it is? Okay. So let's get started. So let me make it too much fun and a lot of knowledge for this session. So stay till end of this session. So the main takeaway is going to be from this session is the knowledge about AWS, the knowledge about AWS machine learning, and much more than that. Obviously, you can able to visualize yourself what will be where you can stand in next 5 years or 10 years in case if you're getting into machine learning. And you can also download a free takeaway ebooks that those ebooks are three must have ebooks. In case if you have not downloaded already, you can download it after this session. Okay, so everything is good now. Let me give a quick introduction about what is this company called Citron Technologies. Okay, so let me just share my browser. I hope you can able to see my browser now. So that's good. So Citron Technologies Private Limited. So who are we? Right. First of all, so Citron Technologies Private Limited. So we are we are based out of Bangalore, India. And what we do? So first of all, we are an IoT and AI company. I mean, what do you mean by IoT and AI company? I mean, so we are not a training-based company. That's the great advantage for the peoples who are attending this webinar, really. So what we do is nothing but so we provide IoT and AI solution for the industries. Usually we work in a domain of manufacturing industries, automobile industries. We provide IoT solutions for them, AI solutions for them. That's how exactly we work. And another part of a company, we also provide trainings. I mean, we do a lot of workshops. We do a lot of trainings on machine learning. We have a domain expertise on AWS, especially. So we all our trainings are revolving around AWS cloud. So we will talk about AWS in case if you don't know what is AWS is also, no issues with that. Yeah. So now let me just tell you guys and what is an agenda for today's webinar in this 90 minutes, what exactly we're going to learn. Okay. So these are the three things. These are the only three things that I want to introduce for you guys today. Nothing else. One is we are going to understand what is the impact of AI and ML in the current world right now, and how it's going to be in next 5 years or maybe next 10 years. And we're going to see why AWS machine learning specialty certification course, why you want to take this certification course first of all, and in case so what will be the opportunity that will be coming along with that, and what is the job opportunities in AWS machine learning, and obviously generally what is the opportunities that is waiting for machine learning today. Okay, so saying this, we will get started. So impact of AI and ML. So this is what I want to start with. Obviously, let's try to like understand and let's try to discuss this particular slide which I'm displaying here. So so use cases in ML and data science, or maybe machine learning, whatever it is. So some of you guys might be new to machine learning, and let's imagine there might be a freshers. I mean, so who are still in the college, probably who are just passed out, and maybe you are a working professional who is working for some company, maybe a corporate, obviously, and you might be a college professor or a lecturer, whoever it is. So generally putting everything for everyone commonly, let's try to talk in that way. So like machine learning, artificial intelligence, data science, those are the buzzwords. Obviously, like that is going to be a buzzword for the next, let's imagine for next 10 to 15 years. Obviously, there is no other buzzword that is going to come apart from machine learning, data science, or artificial intelligence, obviously. So right now it's a trending, obviously everywhere you can see it, may be any kind of industry. So like no worries in case if you're not coming from a machine learning background, that is completely okay. But let's imagine, so in case if I hoping like you are from at least a corporate background, I mean you might be coming from an IT sector, obviously. So the reality is the use cases of ML and AI is existed everywhere. So you cannot like deny that, because you might be coming from a banking sector, or you might be coming from a transportation, education sector, gaming sector, media, hospitality, environment, workplace, anything. It may be anything. So it may be any industry that you're coming from. So the use cases of ML and AI exist anywhere, everywhere. So I mean, so wherever you have an access to digital data, obviously that digital data is an opportunity for you in ML and AI. Basically, you can resolve a lot of problems in the current industry where you're working from, and you can add a much more value to your customers who are who are you are serving for us as of right now. So let's try to discuss on this particular use cases, and we will try to understand in depth. So what are the different types of opportunities that are waiting for us in many different types of industries? So obviously, as I'm displaying here, like I have displayed a lot of different types of industries, starting from banking sector, transportation. So like I don't have a much space here, because if you see, like I have displayed a few number of industries, not everything. I don't have bigger screen like where I can include. If I include more data, obviously you cannot see at the end of the day. So here I have included all the majority of industries where peoples are around. So the few use cases that I also defined over here. So first of all, let's try to understand for the peoples who are not from a machine learning domain. Let's try to understand. Try to realize we are in the age of ML and AI. I mean, we are in the age of ML and artificial intelligence. So to verify that, to justify that, let's take our smartphones itself a best example. So why do our smartphones as a best example? So like we are in the age of ML and AI. I mean, so like when we talk about machine learning, data science, or artificial intelligence, usually what people used to think, okay, AI is a future. Obviously, yes, it's a future, but the future is not something after 10 years or after 20 years. So future is today. So we are in the age of ML and AI. Those things are past, obviously. So right now, let's take our smartphone itself a good example. Let's try to realize we are in the age of ML and AI. So how do we realize that? So let me tell some few ML and AI use cases that we are using in our daily basis. Okay. The first example is, obviously, let's take our smartphone. Every smartphones right now, the latest available smartphones right now, they have a feature called a face unlocking system. I mean, what I mean by face unlocking system is nothing but, so your phone has a so like biometric. Obviously, you can able to unlock your phone based on a biometric. I mean, based on your thumb fingerprints. Similarly, you have a face unlocking system. I mean, you can able to unlock your by using your face. I mean, your front facing camera can able to recognize your face, and it can able to unlock the phone basically. So what is that application? That is not just a software. I mean, it just not a application that is written in Java or maybe Python. So there is more than that. So there is something called a face recognition application is running over there. What I mean by face recognition application, so face recognition, it's face recognition or object or scene detection. There are many different terms what people used to define. So at the end of the day, it is called computer vision. So the terminology, it's called computer vision. So what I mean by computer vision is nothing but anything that you do in terms of images, videos, right? So that is called computer vision. So for example, there are many use cases like face recognition, what you have in your phone, like which can able to unlock your phone. And there are a lot of other things. Let's imagine object and scene detection, what people used to call. Let's imagine if you are trying to analyze a photo. Let's imagine early in the morning you're going to a park. Just imagine that. That's good, right? So early in the morning we are going to a park, and just imagine the scenes in the park. Obviously, you can able to see the beautiful park which with lot of trees, lot of grasses, and a lot of people's walking and jogging with their dogs, whatever it is, right? So this is the scenes, and you can able to identify a lot of objects in it. I mean, a dog is an object, and you may see some parking benches. I mean, you can able to see, and you can sit in that benches if you imagine the park. So there are objects and scenes in it. So basically that is called object and scene detection basically. Okay. So that is one of the application again. And if you see computer vision as a great use case in medical sector, if we discuss, I mean, I have displayed a lot of use cases here. For example, health sector as a huge market when it comes to machine. I mean, if starting from cancer diagnosis, let's trying to identify, do you have a particular person has a cancer or not? It may be a brain cancer, it may be a lung cancer, or maybe a breast cancer, whatever it is. So AI is playing very important role. You don't imagine the market is really huge in when it comes to medical sector. Especially the market means it may be what I mean by the job market inclusive to the product market. So where company different type of companies serving different types of industries in terms of medical sector. So medical sector has a huge use case, and obviously like let's also online shopping. Who denies that, right? Online shoppings. Obviously we are right now in a very hardest situation right now in the due to COVID. I hope you guys are really safe. Be safe. That's the ultimate priority. First of all, be safe. And like right now everything is happening in an online. It may be shopping that you're doing, it may be online shopping, and even people's work from home obviously right now. So no one prefers to go and work in office, the severe situation what we are right now. And one thing you need to realize, the amount of innovation that is going on. So please realize this, the amount of innovation that is going on around us, because we are sticking to, we are working from home. And to enable the workplace work the working from home workspace innovations, a lot of companies right now they are coming with innovative projects into AI obviously. Online shopping, let's take a good example as Amazon, Flipkart, for example, or maybe Zomato. Even that's an online shopping only, like you're ordering a food, obviously. Zomato or Uber, they are putting a lot of innovation in AI and machine learning in order to like be safe, and to, especially when you're talking about Zomato or let's imagine Swiggy, they are putting a lot of innovation to safe delivery, obviously. And when it comes to yeah, Amazon or maybe Flipkart, they are putting a lot of innovation in delivering their products also. If you see like online shopping, if we consider, there are a lot of use cases over there in online shopping, starting from, let's imagine, Amazon car recommendation system. Who don't love Amazon recommendation system, right? Let's imagine, okay, you are really interested to buy a MacBook, maybe MacBook Pro, whatever it is, or maybe some of the smartphones or whatever it is. Let's imagine you're simply Googling in Amazon and you're just taking a look of the reviews, whatever it is, right? And obviously, like Amazon immediately gives a recommendation system saying that the person who searched for this specific product also searched for this specific product. You should not deny it. You can able to see this obviously if you are using Amazon it keeps on recommending it. Otherwise, let's imagine you bought an Amazon from an Amazon you bought a MacBook Pro, let's imagine, and again you will get a recommendation system saying that the person who bought this Amazon Mac sorry, the person who has bought MacBook Pro has also bought some other products related to MacBook. Maybe you might have bought let's imagine additional like things like a mouse, or maybe Apple phone, something else like that, right? So like Amazon used to give some such recommendations. Obviously you can see the such recommendations in Amazon or maybe Flipkart, any other e-commerce website, obviously exemptions in it. So the use cases are existed everywhere. Like let's imagine aerospace industries as a use cases, obviously a space industry, a sports industry, as of there are a lot of use cases. Let me tell you some few use cases in sports industry where you can where we can try to understand the use cases. Like let's imagine who don't like cricket here. Obviously I like cricket. Obviously everyone probably aware about cricket, obviously, right? Let's imagine the amount of innovation that is going in a cricket. First of all, there are a lot of innovation that is going on. Let's imagine starting, I'm talking about the real cricket. Let's imagine a person who is batting and person is bowling. There's a lot of data that is being captured at the end of when the cricket is being performed, and a lot of data is being analyzed in a real time. And let's imagine when the wicket is taken, I mean the when the wicket is taken, there's a lot of data is being analyzed. You can see this crazy ultrasonic sound analysis, and obviously they are using a lot of machine learning at the back end just to analyze whether the data is true or fake. And let's imagine one more use case, like where you can see our ex-cricket man Kapil Dev, right? You might be aware about that one. Kapil Dev has invested in small startup. Okay, so what exactly they are doing is nothing but, let's imagine you are so you want to become a cricket player. let's imagine you want to become a cricket player, and you are a very much beginner in a cricket. You don't know how to swing the bat and how to bowl or how to bat it, how to like perform batting in proper way. So like this particular startup where Couple Dave is supporting. So what is this startup is doing? They are putting a lot of electronics on the bat that you have. Just imagine you have a bat, on the sticker of that bat they are putting a lot of electronics. And what is this electronics is basically is doing nothing but, so this your cricket bat connects to a smartphone that you have basically, and the data is directly transferred from that bat to your smartphone. So what is this really happening is nothing but, so they have a machine learning model. What they have created, this machine learning model is created with the data sets of a lot of best cricket players that we have right now. You can imagine all the different types of cricket players. So all the cricket, based on all the cricket players data, they have created a machine learning model. And now with that data, so you can, whenever you are trying to whenever you're trying to perform a batting, so it can able to, your bat can able to completely monitor the swing, like the way that you're batting, the way that you need to hold your bat. So all this data is being captured from the way that you are batting, and that data is being sent to an Android application where your bat is getting connected, and directly it connects to internet, other things. Obviously that your data based on the data that is being transferred, I mean your data, the way that you're batting, the way that you're swinging the bat. So this data is being analyzed by the model, the machine learning model basically, and that model gives the suggestions for you, saying that whether you are trying to bat properly or not. So this data is being compared to the already the existing cricket players, the national and international cricket players, and it gives a suggestion for you. So the way that you need to bat, the way that you should not bat. So like this is the use case. Again, I can keep on mentioning a lot of use cases, obviously, in a sport industry. Obviously mobiles, I also discussed one use case in a mobile. Face unlocking system is a one use case what I discussed. And again, the great application that I want to discuss in a mobile, right? So that is going to be your the personal assistants that you have right now, like during like when you guys joining our course, I mean when you're joining the meeting, so there is a person called Aditi who is actually inviting you guys to a meeting, if you realize that, right? So it's not me, it's my personal assistants, like how we have okay Google, and we know about Siri from Apple, and we know about Amazon Alexa, right? Those are the personal assistants. They are again called as deep learning technologies. We will talk about deep learning technologies in upcoming slides, obviously. So those are the deep learning devices basically. So you can able to interact with your okay Google, you can interact with your Siri, Alexa. You can tell Alexa to sing some song, or mention some jokes or whatever it is. It can also make some calls, it can able to do some searching, right? It can do a lot of things again. So mobiles has a lot of innovations in terms of ML and AI. So entertainment industries, obviously there are a lot entertainment industries, even like they're using AI in a next level. So because right now, so right now you might be aware about when it comes to media, I mean entertainment sector and movies, if you consider. So you might be have seen a 3D pictures, obviously where they're using VFX for graphics, all those stuff. Soon, like you will see a movies from AI. I mean, by using artificial intelligence, where they are constructing a movies, complete Hollywood movies, you will see that movies very soon. That's how the things are going right now. So hospitality industries, obviously, they have a lot of use cases, medias, gamings. When it comes to gamings, obviously, AI gamings are going to be a next level of gamings, what we can consider. Let's imagine right now we play all the different kinds of games, and soon you will expect the game that is being played by AI. I mean, what, just imagine what if you have a partner. Let's imagine many games will have a partners in the game who can able to play with you. I mean, a partner can be another human being who is might be your friend, who is working, who can able to play a game with you. Otherwise, it can be a bot. I mean, it can be a bot. Soon, what I'm saying, like you don't need a human being, a partner who is a human being who can sit next to you, who can play with you. You don't need such things. Soon you can able to play with the AI. I mean, a complete artificial intelligence, a person who is virtually available for you, who can able to play along with you, play along with that guy. So you will get the same experience how you are playing with your friends, obviously. So that's how the things are going on. So education sector has the huger innovations, obviously. Right now you can able to see the complete education sector has been transformed to online. There is no exceptions in that, obviously, in this hard time. So yeah, there are a lot of technology that is going on in AI. Like a lot of companies are coming with innovative softwares. For it may be anything, it may be for taking a classes. uh, Maybe there might be a shocking things in case if you have a professors are professors are college lecturers don't afraid. Obviously there are companies who are creating a complete AI lecturers, AI professors who can able to teach, the technology. I mean, who can able to teach for students. I mean, AI teacher, AI professor. These things are happening right now because when the things are completely changing it in online, obviously AI can able to play a vital role that can able to deliver efficient results, obviously. So, and obviously right now you can see a lot of every examinations for the students or maybe for the college students or the schools happening in an online. If you consider that, if you see like a lot of softwares are coming, AI based softwares which can able to monitor the complete examination process. It can able to analyze whether the students are doing any malpractice or not. So it can able to completely monitor a lot of things in education sector. So retail space as a huge use case again. Like when you go to a retail shops. Transportation as a use case is obviously banking sector. Where you can see, sorry, yeah, banking sector where you can see the next level of use cases. I mean, if you see banking sector, we talk about many different types of use cases like fraud predictions. I mean, credit card frauds and identifying the just identifying the clients. I mean, what it is called customer churn. I mean, let's imagine you are in a banking sector, like you are working for a bank. Let's imagine a bank called ABC might have some millions of customers. So just by using machine learning, they can try to predict how many customers we may have in next 5 years. Will we have 5 million customers or less than 5 million customers? So it is called customer churn, what it is called. So a lot of companies, even like a retail companies, e-commerce companies, does that, obviously. So there are many use cases that I can able to keep on mentioning, obviously. It may be politics and government. It may be even cybersecurity, smart homes, where we can see the next level of use cases, defense, military and defense, where we can see the next level of use cases in AI. So, so these are the use cases. The use cases are really exploring. It's not exploring. It's exploding. Basically, what I can mention. So this is a global machine learning market. Within the year of 2070 to 2024, obviously. So this is data what I'm representing. It is taken from a marketresearchfuture.com. They put a lot of analysis. So you can able to see this data represents the hardware requirement, software requirement, and service-based industries, where you can able to see the trend which is growing, keeps on growing when we are going further in the years, obviously. So you might be wondering, okay, like there is a lockdown in many countries, and you may think the technology may not grow. It's not the thing. Obviously, whenever we are fed in a hard situations, then only the innovations comes into the market very soon. I mean, um, if you see like every innovation that we are talking about in the world, it may be the first the wheel that is being discovered, or maybe the first rocket that we have launched to a moon. Whatever the innovations that we are made, it just invented for the huge problem that we have solved. Like whenever the humans facing a huge problem, then the innovation actually grows too faster, obviously. Vishnu, thanks for raising a question. So I will answer all your questions later in the session, so you can raise your question. So please raise your hand, those who don't have an access to chat, obviously. So, so obviously we discussed about a lot of use cases. So there is obviously there is no doubt about it. You might be coming from any industry. You might be coming from machine. You might be coming from, let's imagine, a banking sector, agriculture sector, or you might be coming from, let's imagine, space industry, whatever industry. The use cases existed everywhere. There is no doubt about it. Okay, so and when it comes to use cases, we want to discuss about the many different technologies that is being followed in machine learning. So, for example, something called NLP, what it is called natural language processing. So, let me discuss that in a very simpler way. So, natural language processing is a technology where we will deal with much of the words, for example, sentences. So for example, sentiment analysis. Let's have a discussion on this. What is the sentiment analysis? What people used to talk about? Let's take Amazon.com or Amazon.in itself, a good example. Let's imagine you bought a product from an Amazon. It may be any product. Let's imagine it may be electronics goods that you buy from an Amazon something. And let's imagine you bought a product, and whatever the seller has promised, what the Amazon seller is promising for you, it has not been delivered as it is promised. I mean, some of the features in the electronic device that you bought has been not met. I mean, the device might be damaged, something else, right? So what we used to do usually, we used to put a review. I mean, we used to return that product and we will put our hard review in for that particular seller. I mean, we express our sentiment over there. I mean, right? So that is nothing but sentiment analysis. Obviously, Amazon keeps on analyzing your data. I mean, let's imagine Amazon might have millions of customers. I mean, Amazon cannot review all the data, what all the reviews manually by using human beings. It's never going to happen. So that's why Amazon is using artificial intelligence, AI, machine learning for performing a sentiment analysis. Basically, sentiment analysis, they are reading. So the AI is reading all the reviews that is given by a customer, and it is trying to analyze how actually the customers are behaving towards this product. Do they have a positive scope towards that product, or a negative scope towards that product? So this is the innovation which is happening. Based on this innovation, obviously, what Amazon is doing right now, let's imagine if you're going and Googling for, let's imagine yoga mat. For example, if you're trying to buy a yoga mat, for example, so maybe hundreds of dealers might be, hundreds of sellers or dealers might be selling a yoga mat. So how come you might see some 3 or 4 yoga mats which is coming at the first position in the search when you're searching in Amazon.com or .in? So how is that happening really? It's not simply it is coming based on just the reviews itself. It is also based on number of sales that they made, reviews, and sentiment. Obviously, they consider all these criteria. Amazon keeps on trying to deliver the best selling products in Amazon. Obviously, there are a lot of innovations are happening. So there are a lot of things that we can still discuss on natural language processing use case technology. So text classification, classifying a text is one of the good example that we can discuss. Chatbots, which is actually one of the good example where we can discuss. Chatbots are really ruling the world. If you imagine every company has a chatbot, like if you see like Amazon has a chatbot where you can go and discuss, Flipkart has a chatbot. You might, even if you're coming from an e-commerce company, you might be having a chatbot who is sitting where you can able to chat with the chatbot. So right now, if you see, if you see right now, one of the new innovation that we may see in next 1 or 2 years very soon, obviously, right, customer service is one of the good platform where chatbots can able to take a very important role. So right now, if you see any customer service, it may be Amazon based customer service, Flipkart might be having a customer service, or you might be buying some SIM cards from Airtel, Jio, whatever it is. Everyone has a customer service, right? You might see very soon, you might see where they're going to replace human beings with the chatbots, where you can able to talk with that chatbot like how you're talking with a normal human being, where you can chat with that human being. Those things are happening very soon. So this you can expect in next 1 or 2 years. You can expect this technology in place, obviously. And self-driving cars, robotics, obviously this is one of the trending innovations right now. Self-driving cars, obviously, who don't like a self-driving cars? Obviously, all the, like for example, Tesla, obviously, who like Tesla? Obviously, I like Tesla very much. So right now you can see Tesla is one of the first company which comes into the picture when we are talking about self-driving cars or maybe EVs, electric vehicles. Obviously now Tesla is in India. We may expect like EVs very soon, or maybe self-driving cars in India very soon, obviously. And we talked about computer vision, obviously, when I'm talking about these use cases, like anything that you do in terms of images and videos that can be called as a computer vision. So here I have a quick snap, which is actually explaining how the computer vision is being performed. Let's imagine in a retail industries, customer behavior tracking. So let's imagine everyone likes to buy a new cloth during our festivals or maybe different cultural events that we have in a country. I mean, so let's imagine if you're going to a branded showroom and you are trying, they might have different collections in place, let's imagine, due to a festival season. And let's imagine they have this intelligent cameras like this, what I'm representing in my screen, which is actually keep on monitoring your face. Let's imagine you are trying to wear that cloth, or trying to collections. I mean, you like basically everyone, before we buying the cloth in a cloth in the branded showroom, we want to feel how the cloth is. I mean, how smooth it is, obviously, right? And you might need to wear it out. Obviously, you might go to a trial room and might wear it. So what if you have a camera, not in a trial room? Don't worry. After, when you're coming out of a trial room, let's imagine like there is a camera where you come and stand in front of you, like where that camera actually monitors a sentiment. I mean, how do you really feel? I mean, how do you really feel when you're wearing that cloth? So that kind of an use case is obviously, which is again a computer vision. So agriculture industries as a huge use cases, maybe starting from identifying the pests in the crops that they have, and other use cases. Automobile sectors, for example, like here the object recognition and the classification in a traffic. So basically identifying the density of a traffic that you have in the way that you're traveling. Obviously, Google has it. We know that Google Maps has this such technology which can able to give a recommendation saying that which way that you need to travel, which may you can just to avoid a traffic, right? So this innovation is already in place, obviously. So let's go and discuss some further things, and we will try to understand. So the peoples who are new to machine learning, let's imagine if you're very much new to machine learning, you don't have any idea what is machine learning is. In a layman terms, let me help you to understand what is this really a machine learning is. So here I have a beautiful picture of a park which I am displaying. So what exactly you can able to see in this picture? Let's imagine, don't forget about machine learning, forget about AI, forget about data science, everything. So just try to visualize this picture, what you're seeing here, and try to observe the data from it. I mean, I can see a beautiful park, and I can see a lot of grass, and I can see a lot of trees, and I can see a lot of peoples in the park. Looks like probably a morning time, or maybe probably evening time. I can see a bench. I can see a different breeds of dogs here. And again, if you see like this dog which is carrying a ball in it. So what I'm really doing here, let us try to analyze what I'm really doing. So basically, I'm trying to capture objects and the scenes from this picture. So I can see the scene can be a park here, and I can see objects. It can be a bench, or maybe a ball, or maybe a dog, or maybe a different human beings in a different age. I can see all this data. I can observe all this data. So first of all, let's try to analyze. Let's try to question yourself. So I want you to question yourself. How come you know this is a park? I mean, how come this you know this is a park, and how come you know this is a tree, and how come this you know this is a grass, and how come you know this is a dog, and how can you differentiate between different breeds of dog, and how come you can able to differentiate this is a man and this is a woman, and the different age groups? Obviously, how can you do it? So that's let's try to analyze that. First of all, this is how the machine learning also works. Let's consider let's go back. Okay, you might be in 20s or 30s and 40s. Let's go back to our first year, when you're a newborn baby, just a 1 year old baby, right? Let's imagine if I'm displaying a same picture of a park to this baby. If I'm telling that baby to identify an objects and scenes from it, can he do it? No, it is impossible. A newborn baby, barely he or she can able to identify his mother and father, obviously. Other than that, he doesn't know anything. I mean, what if you see like your human brain, so it's completely empty and fresh. I mean, you don't have any data that is stored in your brain, basically. So what happens? Let's imagine then you might go to a play school around 3 years or 4 years, and you might learn some few things: how to play, how to talk, how to walk, right? So what is this? What is this learning that you're really learning here? Is nothing but the data that you're consuming is nothing from your environment. You will learn how to talk your own mother tongue. It may be English or Tamil or Kannada, whatever it is. It may be Hindi. You use the first learning that will come from your parents. Obviously, you learn the language. So then your human brain keeps on putting some lot of data. So saying this, if we see together, then you may go to a primary school, you learn different languages, then you may go to a higher school, then you may go to a job, then you become a senior in your job, then you become a senior citizen, and obviously finally we die. That's not a matter right now. But anyway, so what I'm trying to explain here, the learning curve here, it's keep on exponentially growing. So what is happening here, the amount of data that you consume and you become much more better in it, obviously, right? So the amount of experience what senior persons will have, obviously a kids and the school children or college, they're never going to have it. So what is the understanding here is nothing but this is how really a machine learning also works. Let's try to understand this. Let's imagine, let's take a PC, personal computer, or maybe any high-end server, or maybe any low-end device like Raspberry Pi, obviously. So let's imagine the data, the storage space is completely empty. I mean, everything is in this computer or maybe a server is everything is empty. So now we will take a data. It may be any data that we are talking about based on your use case. So we discussed about many different types of use cases, like a sports use case, maybe banking sector use case, or maybe a medical sector use case, right? So if you consider each and every sector as a different varieties of data. Let's imagine when it comes to medical sector, cancer diagnosis, lung cancer, liver cancer, whatever the diagnosis. So basically we deal with images. I mean, the data will be an image. Similarly, let's take into banking sector as a use case. There, if you see, your data will be much of a integers, string data, obviously. We have a structured data. So if you consider that, so there data might be in a text format, numerical format. So the type of a data really varies. That's a uniqueness, depends on the use case. So so at the end of the day, our job is to teach a data for this machine. So let's consider, so we have a data. Let's take a data which is in a CSV file. Okay, we have a CSV file. So we take this data, we teach this data to your machine. So once your machine has learned this data, it becomes much more better. I mean, it becomes much more experienced in that data. It knows all the patterns in that data. Patterns is nothing but, let's imagine, okay, let's imagine uh, I'm capturing a complete banking data of yours. I mean, let's imagine you are a customer for a specific bank called ABC for 20 years. Let's imagine I can able to capture a pattern of yours in that bank. I mean, what is a pattern is nothing but I can capture what would be your salary range. Let's imagine in 20 years, in 20 years, how many times you had a hike in a salary, and do you got any loans in the duration of how many years you're getting a loan, and such patterns. Those are the patterns basically. So what is this? Let's imagine this data holds the same pattern. I am going to teach all these patterns to my machine. So now this machine is completely aware about, so what exactly, how exactly you behave, I mean your behaviors in that particular bank. Okay, that's good. Now this machine has learned every data from my pattern. So what is the use right now? What exactly that machine can able to do if it is going to learn your data? So here is the answer for it. So so now this specific machine has learned all your data regarding the 20 years of your data, the behavior of yours in the bank. So now this machine can able to make a predictions. Predictions are something that can able to predict what may happen in the future. So it can able to make a predictions, saying that a person called XYZ, so far he is going to get a one more loan. Maybe it can able to make a prediction saying that in the previous patterns what it has learned from you, it can able to tell when exactly you're going to apply for one more loan. It may be home loan, car loan, whatever it is. Or maybe that bank can also predict when will be your next hike in a salary, or maybe any other data that it can able to consume. Or still bank can also analyze and predict, so whether this customer, how long this customer is still going to stay in my bank. Let's imagine a bank can have a millions of customers. How long you're going to stay in that bank? So these are the use cases. So this is the ultimate terms how machine learning really works. We have a machine, we have a data. It may be any data. It may be a CSV file where you have a numbers and strings, or maybe image based data where we teach that data to a machine. Once it has learned the patterns, all those stuff, it can able to make a predictions. I mean the futuristic predictions saying what can happen in the future. So if we want to give a definition, In a proper definition, it can be expressed like this. Machine learning is a study of an algorithms and mathematical models that computer system can use to progressively improve their performance. So basically, it's nothing but, so machine learning is nothing but teaching a complex mathematical models to your computer machine or maybe any high-end server. So once it has learned the complex mathematical models, it can able to make a futuristic predictions. I mean, what may happen in the future, right? Whether it is going to be raining or not, what is the climate today, whether I'm going to get any fraud detection things, or what how long the customer is going to stay in a bank. So there are many for many use cases you may get a many different types of outputs, obviously. Saying this, so what are the concepts that you really need to learn when if you want to become an expert? I mean, this demo is all about AWS machine learning specialty. If you want to become a specialist, what are the topics that you need to be really good at? So obviously, statistics and probabilities. Let me tell you some few insights. If you want to become a specialist, what you want to learn. So the first thing, obviously, we know that now. So machine learning is all about mathematics, all the mathematical concepts that is related to analyzing a data, cleaning a data. There are many different concepts. So where you can start from statistics and probability. So you know what is statistics and probability. It's nothing but the concern that where we collect a data or organize a data, analyze a data, are finding interpretations from the data and representing a data. So in statistics, we learn a lot. So there are many different types of basics that we learn, like called mean, mode, median, standard deviation, variance. So these are the topics where which are going to help you to analyze your data, first of all, to organize your data, to analyze your data. So first of all, why do you need to analyze your data in a first hand? So let me share my real data. Let's imagine, let me share a real-time data of a bank. So this data is going to be in a CSV file. Let's try to analyze what it is. So this is a banking sector data, basically. I mean, I have an individual customer's data here. I mean, I have all the relevant informations of that particular customer. So here you can able to see this. So here I have a CSV file with many features I can able to see from this. I can see what's the age of a person. I have many age groups. I have almost, if you see, 41,000 data sets. What this can be called as a data sets. You can say I have an age of a person and the job role, whether it's a blue collar job, white collar job, whatever it is, and marital status, whether he is married, education status, whether he has got any loans or not, and contact type information, whether he has a cell phone, cellular, and some other details that I can able to use this. So this is a banking sector data where I have all the customer related data. So first of all, so why? So okay, this data makes sense. You have a many different features, particular customer. So then, what is statistics and probability is really going to do that? So so let's also now let's go back to the same example what I discussed here. So let's imagine a school kid or maybe a college kid, whoever it is. Okay, so like the type of a data you're going to learn, it's going to play a very important role, saying like how your future is really going to be. I mean, so let's imagine you don't want you don't want your kids to go in a wrong direction. I mean, they don't want to learn a wrong things in a society. They want to learn a good things in a society, obviously. So if they learn a good things in a society, they will end up in a good citizens, obviously. This is the deal, right? It's the same thing in a machine learning. So let's consider the same data. So this is the same data what we have. Let's imagine always the data that you might have for any use case, it may be, your data might not look good as you expected. I mean, your data might have a lot of garbages. You need to remove that garbage from it before you train that data to your machine, right? So that is the problem. So that's where we use concepts like statistics, probabilities, data engineering concept, basically to resolve this problem, basically. And obviously you have 40,000, I have 40,000, 41,000 columns here. Sorry, 41,000 rows here. I cannot analyze each and every rows individually. I cannot check, okay, what is the age of this person? What is the age of this person? What is the salary? What type of job he has? I cannot analyze just by scrolling this down. So that's where we do visualization. I mean, there we use some visualization techniques where we analyze the data, and there are so many visualization techniques where you can use that one to eliminate the garbage in the data. So statistics and probability is a very important basics that you want to learn. So then we talk about data engineering. So data engineering is nothing but putting some engineering on a data that you have. So there are many data engineering concepts that you want to learn if you want to become an expert in machine learning. So for example, data cleaning, data normalization, there are many different techniques that you want to learn. So data cleaning is nothing but, let's imagine, okay, I have 41,000 customers data here of a bank customer, specific bank customer. Let's imagine this is a data that I have extracted from the server what they have. So let's imagine I cannot expect my data to be completed every time. Let's imagine this person who is 44 years old, who is a blue collar job. And so here I have whether he has taken a loan or not, it tells no. So what if you don't have a data at all over there? That is called missing. You can see this data is completely missing. So how do you deal with that missing data? So you will end up with this problem. This is one of the biggest problem in machine learning. So where we need to figure out a way how to deal with this missing data. And you might have some fake data over there. So somewhere in the column, the values might be unexpected. Let's imagine all the values in this column is from 1,000. What if you have 10,000? So which is abnormal data, the data what we have. So we should also deal with this problems. This is nothing but data engineering. We learn about a lot of data engineering concepts where we want to clean the data, basically organize the data and keep the data ready to teach to your machine. So this is the concepts in data engineering that we want to learn. So obviously, as I told you, data visualization is one of the important concepts. So you cannot visualize the data just in a CSV file, just scrolling down all the 41 columns. Is it possible? No, never, ever. That's where we talk about data visualization techniques. We know like data visualization techniques is nothing but we use different kinds of graphs. Obviously, there are different graphs which can able to give a different insights for you. So for example, let's imagine if I want to analyze a time series data. Let's imagine, let's take a example of weather forecasting. Otherwise, let me throw that weather forecasting. Let me introduce a new use case for you guys where you can understand it clearly. So let's imagine I'm collecting a lot of data from your home, electronic appliances. Okay, you have a washing machine, fridge, water geyser, whatever electronics you have. I collect all the data from that electronics. Let's imagine I'm collecting how much current that is consuming, how much load it is consuming, how much electricity bill that you're paying. I have all this data, let's imagine, for next 3 years. So that is going to be a time series data, correct? So the data that depends on a time, it's called time series data. So if you want to analyze a time series data, what kind of graph we use? Obviously, we may use a line graph. So basically, which can able to where we can have a time in the x-axis and y value will be the feature value basically. So the concept here is you use different varieties of graphs to get a different insights. For example, I'm talking about the garbage data. The garbage data is one of the worst data that you might have in your data sets. In order to eliminate that garbage data, we use different kinds of graphs. For example, you can see here a box plot. So box plot are one of the famous graph that can be helpful for you to identify garbages. Otherwise, it can be called as outliers basically. Okay, so visualization is very important. So where we have to learn how to visualize the data. Otherwise, you won't if you don't know how to visualize the data, you don't know whether your data is clean enough to train your machine. So, and obviously when it comes to machine learning, artificial intelligence, people talk about deep learning. So what is this deep learning is really about? So when it comes to a deep learning, you can able to see people's represent something like this in this picture. If you see, which looks something like a circle, circle, circle. So it's very simple. Nothing, it's not a big deal. It's nothing but the concept that is derived from our human brain. So we know that human brains as a neurons, basically neurons which is carrying information from one part of a brain to another part of a brain as an electrical signal, obviously, right? Let's imagine if you are trying to talk to a specific person who is in front of you, there's a lot of neurons in your brain which is actually firing. in order to transmit that signal, basically. It's the same concept which is actually derived from a human brain. That's how exactly a deep learning works. So you can see all these circles here, which actually represents an individual neuron, which carries some information in it. So each and every neuron in a deep learning holds a number in it, which can be called as a weights. So artificial neural network, what it can be also called, it can have more than one layer. So for example, the initial layer can be input layer, the final layer can be called as an output layer, this can be an input layer. So the middle layers can be called as a hidden layers. This is a concept we're going to also talk about deep learning. We're going to explore deep learning in this particular course in depth. So basically, as I told you, neurons are basically a concept which is actually derived from a human brain. So each and every neuron holds a specific electrical signal. Whenever it has enough signal, it will transmit that signal to a next neuron which has been connected with. So which actually the concept of carrying information. So, and one more concept that we want to discuss when it comes to deep learning. So in case if you're coming from a deep learning background, let's imagine, in case if you're coming from ML background, obviously you might be knowing this. Obviously, when we are dealing with computer vision based applications, I mean, let's take this itself a good example for betterment of understanding. Let's imagine I have this CSV file, which is just 100 kbs or something. I mean, the size of a file is going to be very small. Let's imagine. And let's imagine I have an image data set. Let's imagine I want to perform a cancer diagnostics project. I mean, I want to build a cancer diagnosis project, maybe liver cancer, stomach cancer, whatever it is. I might be holding a image data over there. So comparing with image data, this data is going to be very small. This banking sector data is very, very, very small. So again, if you see this computer vision based cancer diagnosis data might be in GBs, maybe 1 TB, whatever it is. It may be the size of a data can be really huge. So why? So then what is that to be do with cortical columns that I'm talking about here? So cortical columns are nothing but, this is how you might be aware about GPUs, graphical processing units in your computer. A computer has CPU and a computer can have a GPU also. So GPUs are used for processing a graphics. You might be you want to play a game or something, right? Like that, right? Like all the images, let's imagine if you're trying to watch movies, high definition movies in your laptop, your GPU plays very important role. When it comes to machine learning, when it comes to computer vision based application, GPU plays very important role when it comes to machine learning. So let's try to understand how this really a GPU is also working, how that concept is actually derived. So cortical columns are nothing but it's nothing but a specific part in our human eye. So we have a human eye as a cortical columns, so which are stacked something like this, which how I'm representing my screen towards my right side. So you can see I have many different columns. This columns can be called as a mini columns. In each and every mini column, you can have 100 neurons in it, and together I have a stack of neurons which is in a different color, if you see, right? So this is nothing but, this is how our human eye works. Really, it's nothing but how the parallel computing is really happening. So GPUs are designed in the same exact way how our cortical columns are arranged. This is how our human eye works. In the same way, GPU exactly works in the same way. GPU can able to perform the parallel computing. So GPUs are very important when it comes to computer vision, where you want to process a huge amount of data, obviously. So we discussed about neural networks. Obviously, we have the first layer can be called as an input layer, and the final layer can be called as output layer, and whatever the layers that you have in the middle can be called as a hidden layers, basically. So each and every layers what we have here process a different kind of information, and each and every neuron holds a number, what it can be called as a weight. Okay, so let's try to understand one more difference. Obviously, I'm talking about I'm repeating three words continuously: artificial intelligence, machine learning, and deep learning. So what is the real difference between all these three? Basically, they are subsets. When it comes to artificial intelligence, let's take artificial intelligence and hierarchy. Just below artificial intelligence, we'll be having a machine learning. Just below machine learning, we'll be having a deep learning. So for example, So if you see here, best example that I can define for artificial intelligence when it comes to Amazon Web Services, Amazon Alexa or Amazon Lex can be also. Amazon Alexa, we are aware about it. So Amazon Alexa is a device like Google Home where you can interact with that, right? So if you see, and when it comes to machine learning, which is actually a subset of artificial intelligence, okay? So machine learning can technically what it can do, like it can able to power artificial intelligence. For example, let's imagine spam detection can be a good example. Spam detection, identifying the spam, maybe it may be email based spam. So that's a good example in our daily life where we can see like how Google is really doing its good job identifying all the spam emails and sending it to a spam directly, right? So then we have a deep learning. So if you see deep learning, which is actually a subset of machine learning, basically, it's a technique to achieve a complex artificial intelligence. So uh, number of plates detection. So for example, a good learning. Deep learning is a place where we really study about neural networks, where we really do a lot of things in the neural networks. I mean, identifying number of layers we need, identifying number of hidden layers we need. It's so this is the thing. So like artificial intelligence is a combination of ML, machine learning, and deep learning. So the final product that you might see all the time is going to be artificial intelligence based product. I will also give a lot of demos on AI demos on Amazon where we can able to understand it in much more better way. Okay. So, and one more type. So what we want to understand here, the ML types, the machine learning types. So there are three types of machine learning where like most amount of the use cases in the world, they revolve around this particular use cases only. What it is called supervised learning, unsupervised learning, and reinforcement learning. Let's try to understand that one and much more in layman terms. Okay. So supervised learning. What is the supervised learning? How does it look? So for example, let's imagine I have a three different countries coins. So I have ₹1 coin, I have Arab coin, I have maybe a Liberty US coin, I guess. So each and every coin has a specific weight. That is, Indian rupees holds 5 grams. Let's imagine Arab Emirates coin weighs 2 grams and this coin weighs 4 grams. Let's imagine. So the weight of a coin can be a feature and the currency can be a label. So let's imagine when it comes to machine learning, if the coin is 5 grams, if the coin is 5 grams, let's imagine, then it is predicted as it's an, let's imagine it may be a Indian rupee. So basically this is going to be, let's imagine, a 5 rupees. So it can be identified as 5 rupees. The concept here in supervised learning is nothing but a machine will learn based on the features and labels in your data. Okay. So then we have unsupervised learning. So unsupervised learning, simply it is called as learning with no labeled data. So you don't have any labeled data. So here for everything we have a label. I mean, for this particular coin, we have a label saying it's a 5 rupees, it's a ₹1 coin, or maybe a ₹2 coin, whatever it is. Yeah. Okay, it's not 5 here. Let me just erase it. Yeah, it's a ₹1. Yeah. So unsupervised learning is nothing but learning with no data at all. So for example, let's imagine you have a here in the x-axis and y-axis. In x-axis, I have a wickets, and y-axis, I have a runs, where I have clustered different data here, batsmen and bowlers. So based on number of wickets, I can able to say who is a bowler, and based on number of wickets, I can say who is a batsman. So this can be just a clustering process. Then we have reinforcement learning, the last technique. So reinforcement learning works a bit different than how supervised learning and unsupervised learning works. So reinforcement learning, let's imagine this is our machine. It may be a personal computer, server, whatever it is. Let's imagine I'm trying to teach all the different varieties of pet animals what we have. It may be dog, cat, whatever it is. I'm teaching all the different types of pet animals. So to this particular computer. So let's imagine this particular, now I'm trying to make a predictions. I mean, I'm trying to test my machine, whether my machine is performing good or not. So I'm trying to pass a picture of a cat here. So once I pass the picture of a cat, it's going to make a wrong prediction saying it's a dog. So what happens? So it has made a wrong prediction. Then I will give a negative feedback to this machine. So then from that negative feedback, so the machine is going to relearn the data. And again, if I pass the picture of a cat, so it's going to make a proper prediction saying it's a cat. So reinforcement learning is a technique which works based on a reward basis. I mean, each and every time when the machine has learned the feature successfully, we're going to give something called reward, a prize for them. So yeah, so this is called reinforcement learning. So these are the techniques where usually we will revolve around many different types of use cases. For example, supervised learning, a classification based use cases. What I mean by classification is nothing but, so classification can be like this. For example, let's imagine you're trying to identify a difference between apple and orange. So true or false, men are women. So this is a classification. It's a binary classification, either yes or no. Then we have a multi-class classification also, classification between multiple objects, right? So fraud detection can be a good example. Email spam detection is a good example. Diagnostics, image classification, as I told, identifying a difference between apple and orange, men and women. So then we have again a regression concepts. So those can be an algorithms inside. We will talk about that one in deep during our course. So unsupervised learning has a many different types of use cases in a technique called dimensionality reduction, like text mining, face recognition. As I told you, face recognition is a computer vision based use case, big data related use cases, image recognition, clustering based use cases also. So clustering is nothing but the same concept what I am talking about here. So where we cluster a data and we try to make a predictions. So then we have reinforcement learning. So obviously reinforcement learnings are much into, if you imagine gaming sectors, robotic sectors as a very huge use cases on reinforcement learnings, finance sectors, obviously manufacturing, inventory management side. So there are many different types of use cases. So ML types, basically what is the takeaway from this particular slide. So in case if you are a machine learning engineer here, the reality is something like this. So these are the common steps in a machine learning, obviously, where we will start from gathering a data. I showed a data. So like we first of all go and capture this data. It may be a business use case data, or maybe we may go download this data in a public repository. Once we generate a data, then we prepare a data. So data preparation is nothing but we are talking about there might be some missing data, there might be some garbage data, right? So first we need to analyze and remove all those things. Then we need to choose a model. I mean, what type of model that we want to choose. Then once we have choose the model, I mean, then we have to train a machine. I mean, we teach that data to a machine. So once we are training, once our training is done, we do evaluation. So what is this evaluation is nothing but we do testing. So I mean, it's similar to let's imagine a school kids or a college kids, they go for a school for the entire semester and they write an exam. So exam can be a test for them, right? Similarly, to make sure your model is working fine or not, whether it can able to do production job or not, we do test evaluation basically. Then we do hyper tuning. Hyper tuning is nothing but, let's imagine this specific school kid who is written an exam. He didn't perform well in that exam. What we do, like a school can give an extra coaching, or maybe a school kid can go to extra tuitioning, undergo extra tuitioning. So what happens over there? We are basically tuning that student to score good mark in the next examination. So it's the same concept which is derived here, which is called hyper tuning basically. Then finally, once if it is done, we do something called predictions. I mean, this is where we do some predictions. So there are some few steps which are missing here, where a normal data scientist, let's imagine if you're a data scientist, if you don't know how to deploy this model further, you know how to make a prediction, but how do I deploy the model in a production application? That's where the AWS comes into the picture. So we'll talk about that one. So obviously we talked about this, the common algorithms where we keep on repeating, like regression based use cases, classification based use cases, clustering based use cases, and relevant use cases in that. We will discuss about this one during our course in deep. So saying this, okay, these are some concepts that you want to learn if you want to become the basic concept that you want to know before you getting started with, if you want to become an expert, a specialty in AWS machine learning. So now we will answer a question. The second thing that I want to discuss, the first thing is we discussed about impacts. Now we're going to talk about why AI and ML on AWS. First of all, what is AWS is really offering. So obviously Amazon Web Services, when it comes to the picture, Amazon Web Services, we know that it's a cloud platform. So world leading cloud platform. So this data represents that. Obviously, we have many different kinds of cloud platform. We have Microsoft Azure, Google Cloud is there, Alibaba is there. So why AWS actually holding like almost a majority of share in the cloud industry? So that is very simple because they have all the different types of IT services that you need to get started with if you want to become a corporate. Obviously, there are a lot of companies that is using AWS. I cannot just mention in one single slide. So Netflix, Siemens, TCS, everyone. So I cannot just mention everything in the slide, but possibly I try to mention some few companies. So there are here I have mentioned a few who are using machine learning, who are running a machine learning workloads in a production right now. So there are a lot of companies you can see here. We have Siemens, Intel is there, a lot of companies obviously. So there's no doubt about it. So AWS is ruling a cloud industry as of right now. So let's try to discuss about what is AWS is really offering. And so here is the AWS complete ML stack. So there is an updated stack. There are few services, I mean 3 AI services which has been released in last year, I mean in 2020 around December, in AI conclave, I mean in reinvent program. Basically Amazon does the reinvent program every year where they introduce a new services. So I didn't introduce those 3 things here, but remaining everything is covered. So Amazon ML stack can be divided something like this: AI services, ML frameworks and infrastructures. So AI services, artificial intelligence services, nothing but so these are the build service where you don't want to construct any machine learning model. So the machine learning model is constructed by AWS and you can directly go and consume a service from them. So for example, Amazon recognition. So Amazon recognition is a computer vision based application where you can perform face recognition based use cases, object and scene detection use cases. You don't want to construct any machine learning over there. You just use the service. That's how the AI is. Then we have speech based service like Amazon Poly. You might be aware about that one. There is a specific person called Aditi who is actually inviting you guys to a meeting, right? So it's not me, it's an AI assistant who is actually inviting you guys inside. So then we have a text-based services, for example, Amazon Comprehend, Amazon Translation, I mean real-time text translation service, Amazon Textract. Amazon Textract, again, it's a very famously used application in many companies. I mean, a lot of banking sectors, government has a use cases on that. Basically, Amazon Textract can able to document document analysis, not classification. It can do document analysis. So let's imagine if you're uploading a document of let's imagine a medical prescription. So medical prescription has many information, that patient's name, date, doctor prescription, all this stuff. So Amazon Text Extract can extract all the different varieties of information. It can able to extract the hospital name, doctor name separately. It can extract the prescription information separately. So this can able to do some document processing. So then we have a speech-based search service. So we talked about chatbot service, which is Amazon Lex. Personalization service, forecasting. So for Amazon Forecast. So what is this Amazon Forecast? So we are talking about any time series data that you have in the world. Let's imagine we talked about use cases called where you have electricity data of your home, 3 years of electricity data. So I want to make a prediction saying in for the next upcoming 6 months, what will be my electricity bill forecast? I mean, how much bill I may pay, how much electricity it may consume, right? So how do I forecast this? You can able to use Amazon Forecast to do that. So Amazon fraud detector is another AI use cases for, let's imagine if you are trying to perform fraud detection to banking use cases, you can use that. Then we have Amazon Code Guru. Amazon Code Guru is again a AI service. Something into a developer perspective. Let's imagine if you are a programmer, if you're a developer, full stack developer, where you go and write a lot of programs. It may be Java, Python. You use a lot of program if you may construct a front end application, back end application, right? So Amazon Code Guru is a code review platform. It can able to review the code that you have written, and it can able to give a suggestion saying whether your code is working efficiently fine or not. I mean, where you want to make some changes a lot. So then we have Amazon Contact Lens, something related to Amazon Connect, not much important. So AI services, and again, important thing where we're going to explore in deep during our course. And very, very, very importantly, ML service, that is Amazon SageMaker. So Amazon SageMaker is the exact service that I'm talking about, where we're going to spend the majority of our time in this particular course. So Amazon SageMaker is exactly a platform which is built for our developers, where we want to design everything from a scratch. Build, train, and deploy. I can explain Amazon SageMaker in just three letters, what is called B, T, and D. So B for build, building the entire machine learning environment. T for training, training the machine learning model. D for deployment. This is where I'm talking about. In case if you are a data scientist, in case if you are a machine learning engineer already, but you do know how to deploy a model, help you to deploy that model. So D for deployment. So we're going to explore SageMaker in each and every concepts and ML frameworks and infrastructures. So ML frameworks and infrastructures. Okay, one second, guys. I guess let me make sure my network. Okay. Okay, so we are back again. Okay, that's good. So ML frameworks are something like an algorithms that we are talking about. Let's imagine any algorithm it might be. So obviously, when it comes to algorithms, we talked about regression, we talked about classification based algorithms. If you see Amazon Web Services itself, it supports 25 plus algorithms. Amazon has both what it is called inbuilt algorithms. So we will talk about inbuilt algorithms in upcoming slides, and Amazon also has ML frameworks. So ML frameworks like this, which is called TensorFlow, which can be called as MXNet or maybe Gluon CV Keras. So what is this? What's the difference between ML frameworks and inbuilt algorithms is nothing but. So ML frameworks are frameworks which are open source. Basically, if you see TensorFlow is an algorithm which is maintained by Google. I mean, Google used to maintain that completely. And we have MXNet, which is from Apache. Then we have PyTorch. PyTorch is from Facebook. So PyTorch is from Facebook. So they have this particular algorithms are designed to designed for many different types of use cases. Obviously, TensorFlow obviously it supports many things. Obviously, PyTorch is which is invented by Facebook, which is good for computer vision based applications. We know Facebook, right? It's completely which is related to a media. I mean, images, videos, all those stuff, right? So Gluon, CV, scikit-learning. There are many different types of ML frameworks what AWS supports, and deep learning AMIs and containers. What is this deep learning AMIs and containers? This is where we are going to talk about. Amazon Web Services supports what kinds of hardware. I mean GPUs, what types of CPUs. So all those data. Like there are many different types of things which is available in SageMaker. Deep learning AMIs, again a different kind of things, and containers. We'll talk about that one in deep. Elastic inferences, again a different kinds of hardware where you can deploy the machine learning model. So, and again, when it comes to this particular course, AWS machine learning specialty, so we're going to talk about data engineering and data analysis in AWS. We're going to explore many AWS services. For example, let me give a quick snap of all the services what AWS has. Okay, let me share that screen for you guys. Okay, so here is a quick snap of all the AWS services what AWS has. Like AWS has compute related services, storage related services, database related services, migration and transfer related services, customer enablement, machine learning services. This is what we are interested in, right? So we're going to explore all this AI services in deep, and especially SageMaker is our priority. And all the data engineering and data analysis services that I'm talking about, they're coming from. So we're going to explore all the data engineering and data analysis concept which is necessary for this course, like Amazon S3. So Amazon Lambda is not important. We are not going to explore much, but getting to know Amazon Lambda is good. So Amazon S3, which is very, very, very important. Amazon S3 is our data repository. Amazon S3 is a place where we dump all our data sets. I mean, it may be any data set that you have, image data set, text-based data set, we're going to dump inside Amazon S3. So we're going to talk about Amazon EC2, how Amazon EC2 can be used for machine learning, where you can able to host a virtual service basically. Amazon Kinesis. Amazon Kinesis is a streaming service. I mean, when you're working with a real-time data. So what I mean by real-time data, real-time streaming data, I mean, it's not just a real-time streaming data. Let's imagine in the use cases, IoT use cases, for example, where you continuously stream a data to your service, right? And you want to continuously perform a machine learning on it. You want to make a predictions if something goes wrong, right? So you can use Amazon Kinesis for real-time streaming for data. Amazon Analysis, where you can analyze the data. Then we have Amazon Glue. Amazon Glue is a platform where you can able to do some more data engineering like ETL jobs. What it is called, ETL is nothing but export, transport, and ETL, export, transport, and load. So what is this? ETL is nothing but, let's imagine, we talked about use cases. Many different types of use cases supports many different types of data. I mean, not every algorithm supports the same category of data. So for example, so this is our CSV data, correct? So you might have a data in a JSON format, and otherwise you might have a data in, let's imagine, different types of formats called Parquet. There are other formats are available. So let's imagine every algorithm that I'm talking about, maybe TensorFlow, it may be MXNet, PyTorch. Not every algorithm accepts the same category of a format. Every algorithm won't support CSV. Every algorithm won't support JSON. So there is a situation where you want to convert. Let's imagine you want to convert a JSON data into CSV data. So this is nothing but ETL. So we can perform ETL in AWS Glue. So then we talk about Amazon Athena, so where you can able to query a data. So it's basically a query and analysis platform. You can directly query a data from S3 by using SQL statements. So we're going to talk about that. So Amazon Redshift, which is actually a database, and Amazon QuickSight, where you can able to visualize your data without any programming experience. You can able to visualize the data in QuickSight. So usually, if you consider the challenges and the current challenges in ML and AI, if you are not using a cloud, let's imagine. So the usual challenges we can able to put it like this: labeling the data. It's again a big challenge. Labels, we talked about that. Supervised learning, where we have a label and feature, right? And collecting and preparing a data. I mean, collection and preparing a data, that's where we do some data engineering, remove some garbage in it, all those stuff. And storing features. Features can be the targeted variables which actually important for you to make a predictions tomorrow. Let's imagine if we take electricity data. So based on the amount of current and voltage, you can able to make a prediction, right? So there are many challenges like this, maybe checking a biases, picking an algorithm, training a model, tuning a model, finally deploying a model. And once after deploying a model, monitoring a model is very, very important. I mean, what is monitoring is nothing but, let's imagine once after you deployed the model in a real-time production application, so where you can able to monitor that one. So because tomorrow your customers are going to come and input a real-time data. So you may end up with millions of insights. I mean, millions of customers, they're going to come and interact with your model, right? So in order to identify, in order to monitor that, and in order to making sure everything is going good, monitoring is necessary. And implementing CI/CD pipelines along with that, right? How can you do that? Obviously, for that, SageMaker is the best place, as I'm talking about. So as I told you, SageMaker is a platform where you can able to build, train, and deploy your machine learning models in a production-based applications. So Amazon SageMaker supports all the functionalities that we need, all the problems that I mentioned. It can able to take care about for labeling. It can able to take care about collection and preparation. So because it is powered by Jupyter notebooks, and you can able to run a Python code on top of it, and you can construct a model, and you can train a model, and you can deploy a model by using a SageMaker itself in a real time. And you can also enable the insights for monitoring the model. And you can also implement a CI/CD pipeline along with SageMaker Studio itself. So SageMaker provides a studio, which is an IDE, where we can able to do everything. I mean, writing a code, all those stuff. So the studio supports it's a Jupyter Notebooks IDE, so where you can bring your code in it, you can write a code in it. So it can able to automatically taken care of scalability. Also, you don't have to worry about the scalability. What I mean by scalability is nothing but, let's imagine your data might be huge sometimes, your data might be small, the size of a data might be small sometimes. So scalability is nothing but the computation power automatically, it has to be increased and decreased automatically. So that's what I'm talking about. So for example, a quick snap of how SageMaker console looks. This is how it looks. We will explore this completely during our course, obviously. So this is what the missing piece, what I'm talking about. So when it comes to, if you are a data science engineer, machine learning engineer, the one missing piece is a deployment. So this is a typical workflow of any machine learning model, as we discussed already. We start from fetching a data. Then we clean a data. Then we prepare a data. So this 3 steps, where you spend majority of your time, I mean 80% to 90% of your time, you spend just in generating example data or preparation of your data. So once your data is ready, then you start training a model. Then finally, you deploy a model, and then you monitor a model. So this is where SageMaker comes into the picture. Means this entire part can be covered by SageMaker, but the missing piece is this for any data scientist and data engineer. So monitoring and collecting the insights again. So monitoring the real-time data that is coming from our customers. And again, once you have a real-time data coming from a customer, again you can do fetch, and again you can do cleaning, and again you can do preparation, again you can train, and again you can able to do deployment. I mean, this is a never-ending cycle. So you get the data, you train a model, then you deploy it, and again you collect the data from our customers, again you train a model, again you deploy it. So this is a typical workflow of a proper machine learning. As I told you, a common challenges, 80% of a time you spend almost your time in preparing your data. So SageMaker can able to help you to deal with all the problems as I'm talking about, where you don't want to worry about that one. So the common use cases in SageMaker, obviously there are many use cases, not just this use case that I'm talking about. Predictive maintenance, for example, the use cases that is related to manufacturing, IoT related use cases, demand forecasting, retail customers, manufacturing. So I mean, demand forecasting is, let's imagine a particular seller in an Amazon who is selling some products, identifying a demand. What would be a sales cycle in next 6 months? Whether he is going to get less sales or more sales. So fraud detection, again, credit risk prediction related to financial services. So computer vision, autonomous driving, customer churn prediction. There are many different use cases as we have discussed. There is nothing much. And if you see Amazon machine learning in a scale right now, the good example, if you ask me, what is tell me in a real time, what are the use cases which are running? Amazon itself a good example. So 4,000 products per minute sold in Amazon.com or Amazon.in. So the amount of data that is being handled and the amount of analysis that is going at the back end, I mean, reviewing the customer data, all these different types of data. Maybe Amazon Alexa is one of the good example, which is in a production as of right now, right? So this is the all inbuilt algorithms that I'm talking about, where we're going to explore all these inbuilt algorithms in this particular course in deep. I mean, in the specific algorithms, we're going to pick a specific algorithms in this, and we're going to do a real-time industrial project on top of it also. So some other ML frameworks, as we had discussed already. And here is the quick snap of a survey from KDignets. So like this is a trend which is actually representing. So different types of algorithms in the world, and what is a very regularly and very famously used. For example, obviously a TensorFlow, then comes Keras. So this is a good example saying the many use cases are running on that particular algorithms, obviously. So this is about what we are really going to learn in this particular course. Let me give you a particular curriculum. I will explain the curricular information in next slides. So just give me just a 5 more minutes. Let us complete this. So let's talk about the opportunities, what is really available in the AWS machine learning, obviously. Here I have posted some quick snaps that I have taken in Google that I have got it. So here is a machine learning trend, a job vacancy, which is which is not actually, the trend is not actually growing down, it is actually growing up. That's a reality. And you believe it or not. So till date, till 2021, 9th May, till date. So machine learning jobs are the high paid jobs in industry as of right now. So here is a quick snaps that I have just searched in Google, the amount of job vacancies that are available in AWS machine learning. So the opportunities in Mumbai, the opportunities in Bangalore, uh, the opportunities in United States, and some other justifiable data from LinkedIn, 1,000+ machine learning jobs in India. And obviously we know about Naukri.com, which puts a lot of data. Here is the reality. So annual salary range for any AWS machine learning specialty certification guy. So comparing with this particular corporate, this is a data which representing Indian salaries per annum. So the minimum salary is going to be 500K, and the average salary for a person is going to be 1,500K per annum till it goes maximum to 7,000K. This is a data that is got from Glassdoor. It's not something that I had driven it. You can able to Google it and you will be able to get this data. So this is the thing, and some of the FAQs, if you are going to attend this particular, if you're going to register for this particular course, the from frequently asked questions. Do you need to attend all the sessions on both the days? Let me give a clarity on dates, all the stuff. Yes, you need to attend all the sessions. Recordings will be provided. Whether recordings are provided to the participants, yes, recordings will be provided. About certification, I mean, the participation certification will be provided for this particular certification course. And obviously you can also write exam, AWS machine learning specialty exam from Amazon too. So what are other opportunities that we are providing? So every registered participants in this particular course, they will be given a further support in our community. I mean, it may be a WhatsApp group or a Slack group that we have, where we'll keep on supporting you guys, spreading a lot of opportunities, free webinars, or maybe job opportunities, whatever it is. Opportunities for students. Students can able to apply for internship opportunities. That is also possible. And what is the prerequisites to register for this particular certification program? So any person from science and engineering background, they can able to register for this particular course. So, and I mean, so if you have a the understanding of, let's imagine how to use the internet, and you have a basic understanding of any programming language, that would be more sufficient to get started with this course. Regarding other prerequisites like installation of a software, other things, we will let you know. Don't worry about it. So this is how the dates are, how long it will take. So we're going to get started from 29th of May. I mean, end of this month, we're going to start. So this is how the dates are. So this is all our weekends, not weekdays. 26th, 30th, 5th June, 6th till 20th June, every Saturday and Sunday, we're going to have a course. So the timings are something like this. If you're joining from India, so the course time is going to be 1 p.m. to 5 p.m. And a different time standards has been given here. You can able to compare it. And who is this certification really for? So obviously, the audience would be, the priority would be, for example, freshers who want to get started. I mean, starting from them, and very higher priority would be for a working professionals who are already working, who want to get into a machine learning. And obviously, working professionals like professors or maybe lecturers can be a targeted audience here. And so what is a planned curriculum? So the planned curriculum is something like this. Data engineering concepts are 20% included. Exploratory data analysis concepts are 24% included. Data engineering concepts are like data engineering on AWS. So all the data engineering services that I have given will be discussed, and we'll be doing a hands-on. Exploratory data analysis concepts, modeling, and machine learning implementation and operations, that is going to be 20%. So before I'm showing some curriculum, before we going for an questions, let me also finish other FAQs. So I'm a fresher, can I attend? Yes, this course is also designed for getting started for freshers also. We'll be getting started from basics, and any programming language required. Yes. So if you have any basics understanding of any programming language, and if you know Python, you will be most welcomed. Obviously, we'll be exploring, we'll be getting started with Python. I mean, we'll be starting from refreshing a Python basics. I mean, we'll be starting from refreshing Python basics. That doesn't mean I will be conducting a Python course. It is not Python course, it's a machine learning course. So obviously, will you cover projects and implementation? Obviously, let me show a data for you guys. So we will be performing a more real-time projects. I will show the data right now. So I just want to tell you guys this one, so because this is a reality. So if you consider right now the media, I mean the cameramans and or maybe the cameramans, it may be a Hollywood movies or maybe at maybe any news media, whatever it is, right? So right now you might be seen in the old 10 years back, a cameraman who is carrying cameras in a helicopters, aeroplanes to shoot a movie. Right now, this technology is being, this problem is being solved in next 10 years just by using a drones. You can see no one is going to take a helicopter or a chopper to do a Hollywood movie. Just they have a high definition um, uh, um, um, high definition helicopter choppers like this, so like a drones like this, which can able to shoot an Hollywood movie for you, right? So what I'm trying to represent, within 10 years, this innovation, just the complete industry has been changed here. I mean, the bigger problem has been solved. Just imagine the such a scale, you can able to see 3x of opportunities in machine learning right now. So in this particular AWS machine learning specialty course, where we are targeting is 30 plus of hands-on experience. I mean, all the concepts what I'm talking about, data engineering, data analysis, modeling, and exploratory implementation of models and deployment of a model. We're going to do a 30 plus hands-on experiences, real-time industrial projects. We're going to take a real-time data on a specific algorithms. We're going to construct a real-time project, and a dedicated mentoring will be provided. So this particular course, what we are planning is for 32 hours, where we are starting from 29th of May, and it has 20 plus of 20 hours of assignments. What I mean by 20 hours of assignments, I think, but when during our sessions, we give some assignments where you can go and practice much, obviously. And let's talk about course fee, and then we will finally go for a Q&A. So the course fee is something like this. So this is the course fee, you won't believe, this is one of the best price in the world, what I can promise. Let me also justify it. It's not something that I'm just babbling. It's actually the reality. So we are not a training based company. We don't want to be a training based company. So this course, what we are trying to provide is in collaboration of AWS. So where we are offering this course starting from 10K per person. So with this 10K, so we have two types of tickets. In case if you're registering as an individual, you can go for a individual ticket, which is a 10K. And then we have a group ticket in case if you're coming with a group of 2 people. Let's imagine you're registering for your friends, you also get some opportunities. I mean, only difference between these 2 tickets is if you're registering as a group, you'll be getting a 10% discount per person with $50 AWS credits for free. With this credits, you can explore AWS completely for free for next 1 year. So this is the course structure and the course fee what we have. So this is a reality. The actual price in the market is something like this. It's in pounds. You can able to see it's in 1,400 pounds. So just imagine we are just charging like a 10% or 20% what they are charging from what's the actual fees. Just Google it. Just get some more justification on what is this course is. Actually, what's the course fees justification is. So why do you need to really care about Cyton Technologies? Why do you feel like we are the best persons to teach you guys? Obviously, like we are a company based out of Bangalore, private limited company, and we are supported by Department of Science and Technology, India, and we are incubated in PSG Step, Coimbatore. And we are in a part of Nidhi EIR, what it is called, supported by Department of Science and Technology. You can Google it, you will get our name over there. Some other awards and opportunities what we had. So we are being awarded as a best startup from FKCCI Bangalore and some other awards. We developed some lot of innovative products for companies like Reliance Unlimited. So we developed an IoT product for them. So we are part of AWS Activate program, so where AWS support us in product development. So that's how we have a domain expertise in AWS. And some other student feedbacks. It's not something that we are doing this course today. We are doing it almost for 3 years right now. We do a lot of webinars, a lot of courses, a lot of workshops. Some of our customer feedbacks on our courses and our workshops that we did. So this is all I have. Some other offline classes, snaps. We do offline classes, obviously, from Bangalore. Obviously, we cannot do it right now. So these are the things what I want to show you guys. So what's the deal with this today's class? So those people who are interested to register, you can register for our upcoming course. I will email you guys the registration links and course curriculum. So now you guys can directly go to Q&A. You can unmute your mic. You can ask your questions. I can also show you guys a curriculum here. So before you guys getting started to ask me a question, let me give a brief on a curriculum, what I'm displaying, what we're going to learn. So we're going to start from basics. As I told you, refreshing basics will be our the first thing that we're going to learn. So the 8 hours that we're going to start discussing our basics. I mean, we're going to start from Python basics, and I will share this curriculum via email for you guys, where you can explore this in deep. So Python basics, pandas, wherever I have mentioned and hands-on means there we're going to perform a real hands-on lab, hands-on experience. So statistics and probability, where we're going to do a lot of hands-on in statistics and probability, where we're going to learn about mean, mode, median, probabilities, density functions, mass probability, mass function, other concepts, data engineering concepts. So once we are done with that, this is where we're going to learn about data engineering in AWS. So this is where we're going to learn a lot of AWS services, data engineering services like Amazon S3, Glue, as we discussed, Kinesis, data store, pipelines, batches, a lot of other concepts. Data analysis, so where we're going to learn about all the data analysis concepts like, as we discussed, Athena, QuickSight, other concepts like Hadoop, EMR, Apache Spark, and very importantly, modeling in AWS. So this is where we're going to talk about all the deep learning concepts like what are the different types of neural networks, convolutional neural networks, recurrent neural networks, some other techniques to evaluate your model. All the AI services will be discussed, and we'll be doing a lot of hands-on. And very importantly, Amazon machine learning using SageMaker. So this is where we spend, as I discussed, the majority of our time in Amazon SageMaker. So we're going to take a look of all these inbuilt algorithms as we discussed, and we're going to perform real-time industrial projects and all the algorithms that I mentioned here. And finally comes model deployment, all the stuff. And we're going to discuss about all the ML frameworks, what SageMaker supports, like TensorFlow, Apache MXNet. Finally, we'll end up our course by monitoring and watching. This is a concept which is important, where we end up in monitoring and watching. So once after you deploy your model, it is necessary for us to monitor and get that data. Once you monitor only, you will come to know whether your model is working fine or not. So let me share this curriculum through email, so where you can download. So for the people who have an access to chatbot, to a chat, you can download from a chat window itself. Let me share the download links in a chat. In case if you don't have an access to chat window, no worries. You can take a quick snap of this particular links, where you can download. So here, this is a link for registering to our course, and this is a link for downloading a curriculum. For those people who don't have an access to chat, you can take a sneak snap. So now you guys can talk. I am open to questions. Yeah, sorry, we took like bit of more time what we have expected. Yeah, so I'm open for your questions. You can unmute your mic. You can talk. So in the meantime, let me also share a download link for ebooks. Yes, please go ahead. So those who have a questions, you can unmute your mic and you can ask me a question.
Hi Sharad, Maheshwari
Hi.
here.
Hi, Mahesh.
I saw like list of services like S3 and few other things. Will 2 hours be
Exactly.
sufficient for covering all those, and also for the next section? I just saw it in the curriculum that you have
Okay.
shared. So
Yeah.
was it
So
only very brief about those things,
see,
those
it's
services?
not just a hours. It's not just a 2 hours. This course is for 32 hours. 32 hours completely. It's not 2 hours. It's 32 hours course. It is.
No, the specific section that you mentioned,
Mm.
it was in one of the pages. So
Yes, yes.
some services are covered only in like kind of 2 hours.
Okay. See,
So
okay. Let
yeah,
me clarify it.
it's 8 hours
Okay.
and about yeah.
Yeah, data engineering, it's 8 hours is more sufficient. So because we're going to discuss on S3 and we're going to perform some hands-on on it, and especially when it comes to let's imagine data analysis concepts. So these are the basic concepts of data analysis, like how to use QuickSight. For example, let me justify it. So in order to use QuickSight, you don't need any programmatical experience. I mean, QuickSight is a drag and drop platform. You can, if you have a data of JSON, CSV data, just come and upload it, then you can generate an insight. So the priority, Maheshwari, what in this particular course is
Okay.
SageMaker. SageMaker is a
Okay.
place where we go into our majority of our time. 10 hours will be spent in SageMaker. So because SageMaker is a very important topic that we have to cover in this entire course, obviously. Obviously, we are doing this for the third batch right now. So we have covered what we have expected in that particular time. So it is more than enough, obviously. Yeah.
Okay. Okay. Thank you.
So let me share the link for downloading 3 machine learning ebooks. So this ebooks will be just on handbooks. So when you're getting started with the machine learning, um, you need to have this ebooks just to for a beginners. So you can use this link to download a free ebooks. So those people who don't have an access to chat, you can just take a snap and you can enter these details. I will share an email for everyone, a registration link of this particular course and other information, so you can proceed further for the registration. And so obviously this course is just for 10 peoples in a batch. We are not looking forward for more than 10 peoples. It's just for 10 peoples because we will be doing a lot of hands-on, and I want to like we want to really take care about all the people who are attending this course. So that's why we're not getting a lot of peoples in the batch. Just a 10 peoples will be sufficient for this course in a batch. So in case if you have a question, please ask your question, and any other informations or any information that you want to know,
Hello,
I'm here to answer. Yes, please. Yes, please. You can
can you hear me, sir?
please. Yes, yes, I can hear you. So you can just mention your name and you can talk.
Yeah, this is Vamshi.
Yes, Vamsi.
Hello.
Yes, yes, yes,
Yes, sir.
yes,
Can you hear me?
yes. I can hear you. Yes, go ahead.
Okay, sir. Is it paid course or a free course, sir?
It's a paid course.
Okay, okay.
So this is a
Like as
price.
you shown in the slide.
Yes. So this is a pricing what we have right now. So we have a two types of tickets. So in case if you're registering as an individual, which where you can just pay 10,000 rupees per person, and in case if you are joining as a group of two people's ticket, so we have some discounts that you can also obtain. Yeah.
Okay, thank you, sir.
Please let me know if, in case if you guys have any other doubts, even other than this, you can ask anything related to ML and AI. I can able to help you with it.
Hello, I'm Sheetal here.
Hi, Sheetal. Yes,
Yes. So, how you people will be helping in this certification? Means we have to appear for an exam, right? For getting the
exactly.
certification. So,
Yes.
how you people
So
will
like
help in that?
so so like in terms of technology wise, I mean, so we can able to make sure in this particular course we will make sure like we cover everything that is related to certification, and we do a lot of quiz. I mean, we give a lot of quizzes. I mean, that's an exam. It's a small examination that we provide before you getting before you write an exam. So it's the same exact question formats what exactly the question format AWS will provide during an examination. So we provide this kind of a support. Not only this, thanks for asking that question, Seetal. So one is examination support will be provided like this, providing sample questions dumps, sample question dumps, and giving this quizzes and making sure we cover all the syllabus what we have showed right now. It is according to AWS machine learning specialty syllabus only. And more than that, the peoples who are going to join our community, I mean, so people who are going to register for a course, so for them also, like, we'll be keep on providing a lot of updates related to jobs, I mean, in terms of companies who are hiring for a skill set, who is looking for AWS machine learning. So this is again a kind of a support what we provide, Sheetal. Yes.
And what will be the certification fees after this, after the course, approximately?
So okay, so AWS machine learning certification course fee will be around in INR, I can tell, like 23 to 24,000 rupees, I guess. Yeah.
For certification, for appearing for that exam, right?
Yeah, if you want to appear for that exam, you need to separately pay for that certification exam. Yes.
So that will be 23,000, right?
Yes, around 22 to 24. Yeah.
Oh, okay, thank you very much.
So I will spare a few more minutes in case if you guys have any doubts, you can ask me.
Hello.
Yes, madam. Yeah.
Hi, I am Alka this side, and I want to know in S3, do we have an option of load balancer available,
So like
and how
so
we help that is helping us in handling big data analytics?
exactly. So the thing is, S3, that's a great question. So because S3, which is actually a managed service, so there is a difference over here. So managed service is something called, which is managed by AWS, where you don't want to worry about load balance, all the stuff. It is auto scalable. So what I mean by auto scalable, as I expressed during our slides, auto scalable is something like, let's imagine the amount of data transaction you might be having per day, 1 GB, for example. And let's imagine around after 3 or 4 5 years, the amount of data that you might transfer, let's imagine per day you might transfer 1 TB or petabytes of data. So in order to handle such a load, for example, let's imagine, so do we have any load balancer that we need to configure, that we need to work out on AWS? No, there's nothing like that. So it is auto scalable, which is managed by AWS. So yeah, the scalability can be taken care by AWS. There is no job that you want to do in terms of scalability over there. So that is the answer, quick answer for that. So
Okay, and what about data deduplication? That is also managed by AWS only.
So data duplication even include that, or maybe version management also can be taken care by S. So in case that, like, I will share you a web we conducted recently. Let me link on so where provide some more clarity. So especially in this particular course, where we're going to explore S3 in deep. So S3 has many, as I told you, it's a version management in terms of data, or maybe it has classes in maybe could you ask?
Is there any services available in Amazon through which we can work on load balancer data deduplication?
Yes, EBS, Elastic Block Storage. Yeah, EBS will be a platform for that. Yeah.
Okay. So do you have some videos or something like that related to, or some
So
hands-on?
related to EBS, I can share some resources. I can directly share some hands-on, step-by-step hands-on guide. It's a document, it's not a video. What I can share directly from Amazon. Yeah.
Thank you so much. So can I
So
have your email ID or the same
yes.
one that we are getting?
So if you want the email ID, this is my email address. Let me just type it in my screen. email you guys all the information, so you can also find mail in the email that I'm going to. Yeah.
Or is there any open source cloud services that are available that can give the services like data deduplication and your file management,
Okay.
where we
See,
can
open
design our
source.
own management system?
Okay, that's good. That's a good question. So, do you mean open source? Do you mean, see, like, first of all, one thing we need to clear, any cloud platform that I showed you, it may be AWS, Google Cloud, Alibaba, or maybe anything. All these cloud platforms are paid services. There is no cloud platform that is actually a free, because obviously there are thousands of peoples and thousands of people who are working on AWS, who is managing a hardware, who is managing a software. So obviously in that part of considering that point of view, there is no cloud platform which is actually free. I mean, in terms of open source. In case if you're considering, do I have a software, especially in terms of load balancer or something that I can able to download from an internet, and where you can able to use your PC itself in environment? Yes, there are softwares, but as a cloud is much into managed platform. I mean, when it comes to hardware, when it comes to management of electricity network, will be managed by cloud platforms like AWS, Microsoft Azure. Those cloud platforms, you cannot avail the open source software for free. I mean, yeah, you need to pay. Even if they provide a software for free, you need to pay for the resources that you're going to consume, the space, the electricity, the network that you're going to consume, you're going to pay. Yeah.
Fine. Thank you so much.
You're welcome. Okay, so in case if you guys have any more doubts, you can ask me, else we can end up our session. So let me stop recording.